My name is Juan David Marulanda, and I am going to present the article of obesity and addiction, neurobiological overlaps. So, first of all, we need to understand what is obesity. And well, we all need to eat, and to be honest, who can resist to a very good meal? So, obesity is a disease that involves an excessive amount of body fat. In evolutionary terms, this property of special foods was used to be advantageous in environments where food sources were scarce because it ensured that food was eaten when available, enabling energy to be stored in the body as fat for future use. However, in societies like ours, where food is plentiful, this adaptation has become a dangerous problem. But if we know that eating too much is dangerous, why do we get addicted to food? Actually, we don't just get addicted to food, but to many things such as drugs, alcohol, or anything that causes pleasure in our minds. This is because different substances produce a euphoric feeling by triggering large amounts of dopamine in certain regions of the brain that are responsible for the feeling of reward. So being high in dopamine and then stop and then again being high in dopamine is what makes you create an addiction because the brain has dynamic and flexible processes that dictates the behavior and choices of the people. So, for example, some people are conscious for moments that they must stop eating or consuming drugs, but in some other moments, they are craving for them. However, just as most individuals that consume drugs are not addicted, most individuals that eat excessively are not addicted. Dopamine is a type of neurotransmitter that your body makes and your nervous system uses to send messages between nerve cells. Moreover, dopamine plays a role in how we feel pleasure, and it is a big part of our unique human ability to think and plan. Our brain has its own reward system. So when we do certain things, the brain rewards us by making us feeling good. The brain reward system is a brain circuit that causes feelings of pleasure when it's turned on by something we enjoy, like eating food or being in love. Whenever this reward circuit is activated, our brains note that something important is happening that's worth remembering and repeating. When related to drugs, they produce an artificial pleasure and sense of reward for the brain. There are some differences between the drugs and food and how they are perceived by our brain. Drugs actions are triggered by their direct pharmacological effects in the brain reward dopamine pathway, and food is modulated by multiple peripheral and central mechanisms that directly or indirectly convey information to the brain's dopamine reward pathway with a particular prominent role of the hypothalamus. There are also some similarities between drugs and foods. For example, when non-obese male subjects were asked to inhibit their craving for food while being exposed to food cues, they exhibited decreased metabolic activity in the amygdala and the occipitofrontal circumference, and these decreases in the occipitofrontal circumference were associated with reductions in food craving. A similar inhibition of the metabolic activity in the occipitofrontal circumference has been observed in cocaine abusers when they were asked to inhibit their drug craving upon exposure to cocaine cues. Some insights from the article are that obese individuals exhibited less activation of reward circuits from actual food consumption than lean individuals, whereas they showed greater activation of somatosensory cortical regions that process palatability when they anticipated consumption. This happened because they are used to eat more, so they don't feel the same reward as someone that is not that used to it. Also, in some preclinical and clinical studies, were evidenced that the dynamic associations between the changes in neuroendocrine hormones like insulin triggered by food restriction and brain dopamine signaling. Moreover, some recent reports showed a relationship between addictive personality and maladaptive eating behaviors. Taking together these results strongly suggests that the possibility of food and drugs may be competing for overlapping reward mechanisms. With all this said, we can conclude that the ability to resist the urge to use a drug or eat past the point of satiety requires the proper functioning of neuronal circuits involved in top-down control to oppose the conditioned responses that trigger the desire to ingest the food or drug. Moreover, there are several identifiable circuits in the brain whose dysfunctions uncover real and clinically meaningfully parallels between the two disorders. So the picture that is emerging is that obesity, similar to drug addiction, appears to result from imbalanced processing in a range of regions implicated in reward, motivation, stress reactivity, self-control, in addition to possible imbalances in the homeostatic regulation of food intake.